Hey, welcome to Superchain Vibes, the show where we dive into the world of Ethereum scaling, layer 2s, and, well, everything in between. Today's deep dive is laser focused on explaining the superchain. What exactly is it? Why should you care? And how might it reshape the future of blockchain infrastructure? If you've been hearing the term superchain floating around, maybe in crypto circles, and are looking for some clarity, yeah, you've tuned into the right conversation.
That's right. The superchain is a concept that's generating a lot of buzz, and definitely for good reason. At its core, it's Optimism's ambitious vision for a truly scalable blockchain ecosystem. We'll be unpacking what that vision entails, the foundational principles behind it, and, the technical roadmap to get there. Think of layer 2s as faster, more efficient highways built alongside the main Ethereum blockchain road, right, to handle more traffic. The superchain aims to connect many of these highways into a single, powerful network.
Okay, let's unpack this then. The first thing that jumps out is this idea that maybe current blockchain tech isn't quite cutting it for the decentralized web we all envision. Mm-hmm. Why is the superchain being talked about as like a necessary step? What's the fundamental problem it's trying to solve?
Yeah, the crux of the issue is scalability. I mean, even going back to the early days of Bitcoin, there were concerns about whether a single chain could handle the transaction volume needed for, widespread adoption. That challenge hasn't gone away. While individual layer 1 blockchains have made progress, the reality is that for the decentralized web to truly flourish, we need a magnitude of increased capacity. Imagine if every single web application tried to run on just one blockchain. It'd quickly become congested and prohibitively expensive to use, like trying to fit the entire internet's traffic onto a single dial-up connection, basically. And a key challenge here, maybe one we don't talk about enough, is ensuring all the transaction data is publicly available and verifiable. This is what we call data availability. That's crucial.
Right, it's like trying to fit the traffic of the entire internet down a single lane highway.
Makes sense. So what's the potential then if we do solve the scalability puzzle? What's the imagine if scenario that makes the superchain so compelling?
Oh, the potential is immense. Imagine developers being able to focus solely on building their applications without needing to worry constantly about the underlying blockchain infrastructure. The network would just handle it, scaling automatically. We're also talking about supercharged composability. Because all these applications would exist within a shared execution environment, they could interact with each other in ways that go far beyond traditional APIs. Think of it as like Lego blocks for decentralized apps, just clicking together seamlessly. Imagine decentralized insurance protocols seamlessly interacting with prediction markets based on real-world events, all within the same execution environment without complex bridging. That level of interconnectedness, it could spawn entirely new financial primitives. Okay, here's where it gets really interesting for me. You also mentioned standardized gas markets. What does that mean for developers and, users?
Exactly. Today, developers often have to shoulder the infrastructure costs for their users, which can be a huge barrier to entry, especially for, viral applications. With standardized gas markets across a highly scalable network, those burdens could be significantly reduced. This could lead to a world where microtransactions, say within decentralized games or social media, become economically viable at a massive scale. That's something currently hampered by unpredictable, often high gas fees, right?
Absolutely, yeah.
Developers could explore new monetization strategies, and users wouldn't necessarily need to worry about those fluctuating fees for every little interaction. Ultimately, solving scalability makes blockchains a viable and attractive tool for all developers, not just those specifically focused on decentralization today.
And it's not just about speed and cost, is it? You touched on cryptographic verifiability earlier. How does the superchain enhance that, and what are the implications?
That's a key differentiator, yeah. When more data and activity move on-chain in a scalable way, more of our digital interactions become cryptographically verifiable. This unlocks some really powerful possibilities, like transferable reputations that aren't tied to a single platform. Imagine your reputation as, say, a reliable participant in one decentralized application being recognized and portable to others. Similarly, users gain greater ownership and control over their data. It reduces the risk of losing access or being subject to the whims of, centralized entities. It's fascinating to think about a future where your positive contributions in one online community could actually give you a trust score in another that could really change how online interactions work.
So the superchain is Optimism's answer to this need for scalable decentralized compute. Yeah. But it's important to note, as the sources point out, that it's very much a vision in progress, right? Not a finished product you can just download today.
Precisely. Yeah, the superchain, as it stands, is a concept and an ongoing project. Its ultimate form will be shaped by the contributions and innovations of the entire Optimism collective, the community. This documentation and our discussion today represents the best current understanding of its components, features, and roadmap, but it's definitely an evolving landscape.
Okay, so what are the core foundational ideas behind the superchain? The concept of horizontal scalability and why multiple chains are necessary seems pretty fundamental. Can you break that down for us a bit?
Absolutely. The core idea behind horizontal scalability is that to significantly increase the overall computational capacity, you need to run chains in parallel.
Yeah.
Think of it like adding more servers to handle increased web traffic. The limitation of a single blockchain is that the hardware requirements to run and sync it increase with the amount of computational work it performs. So to achieve true horizontal scalability, you need multiple independent chains working in concert.
And a chain in this context is more than just a ledger, right? That it's a state transition system. What does that mean practically?
Exactly. A chain is essentially a system that starts with an initial state, has a set of rules, state transition function, that govern how that state changes based on inputs, which are the transactions. And these changes are cryptographically secured and can be independently verified by anyone. Imagine a simple digital bank account. The state is your balance. A transaction is the input. The state transition function is the rule that adds or subtracts from your balance. The chain securely records and verifies these changes.
Okay. Now, we've had multi-chain architectures before. What are the limitations of those sort of traditional approaches that the superchain aims to overcome?
Right. Traditional multi-chain systems often introduce a fragmented security landscape. Each new chain typically has its own security model and its own set of validators or block producers. This not only increases the overall systemic risk because a vulnerability in one chain could potentially impact others, but it also makes launching new chains costly and complex. You need to bootstrap an entirely new security apparatus every time.
And this is where the superchain's approach of leveraging layer 2 chains on a shared layer 1 becomes crucial, right? How does that address these limitations?
Yes, exactly. By building on a shared layer 1 like Ethereum, the superchain ensures a standardized security model across all its constituent layer 2 chains. Each L2 chain benefits from the security and consensus mechanisms of the underlying L1, so it removes the need for those independent validator sets. This makes deploying new chains much, much cheaper, and it reduces that systemic risk.
That makes sense. Traditional multi-chains have faced security fragmentation. I guess while the shared L1 approach sounds promising, are there any potential drawbacks to relying so heavily on a single layer 1 for security of potentially many chains?
That's a good question. One potential area to watch is definitely the overall load and potential congestion on that underlying layer 1 as the superchain grows. That's something the ecosystem will need to manage carefully.
Okay, so instead of thinking of individual isolated blockchains, the superchain wants us to see them as, like, interchangeable compute resources. That's a powerful shift in perspective.
Precisely. The goal is to abstract away the underlying individual chains and treat the entire network as a single unified compute platform. This commodification of chains allows developers to build applications that can operate across multiple chains seamlessly, and they can do that without having to worry about the complexities of different security models or high deployment overhead.
And this leads to the definition of the superchain itself, a decentralized platform of many chains sharing security and the OP stack. That standardization seems key here, enabling uniform interaction for tools and wallets.
Absolutely. The standardization provided by the shared OP stack is really what allows this network of chains to function as a cohesive unit. It means that wallets, developer tools, other infrastructure components, they can interact with any chain within the superchain in a consistent way.
You also mentioned OP chain. Is that just another name for a layer 2 within the superchain, or is there a distinction?
Close, but there's a slight distinction. An OP chain is specifically any chain within the superchain that is officially governed by the Optimism collective. Think of the superchain as maybe a country, right? The OP stack is the set of common laws and infrastructure. And OP chains are like cities officially recognized and governed by the national government, the Optimism collective. Other projects might build towns using similar laws, the OP stack, but they aren't part of the official country in the same way. So while all OP chains are layer 2s using the OP stack and contributing to the superchain, not every OP stack-based chain is necessarily an officially governed OP chain.
Ah, okay, that clarifies it. So to become this superchain, Optimism needs to achieve certain properties. What are the essential ingredients, the must-haves?
There are 5 key properties outlined in the documentation. First, a shared layer 1 blockchain that's needed to provide a total ordering of transactions across all OP chains. Second, a shared bridge for all OP chains to ensure standardized security properties. Third, the ability to deploy and transact on OP chains cheaply without being burdened by high L1 fees. That's critical.
Yeah.
Fourth, configuration options for OP chains, allowing them to customize aspects like their data availability provider and sequencer. And finally, fifth, secure transactions and cross-chain messaging capabilities, so users can safely move assets and data between OP chains.
Got it. Now, achieving these properties requires some pretty significant technical upgrades to the OP stack beyond what Bedrock delivered. Let's dive into those key changes, maybe starting with upgrading the Bedrock bridge to act as a kind of chain factory. What does that actually entail?
Okay, yeah. So Bedrock already laid some groundwork by defining parts of the L2 chain configuration on L1 through the system config contract. The next step is to extend this so that all the information defining an L2 chain, including its unique ID, key configuration parameters, everything resides on-chain on L1. Once all this data is on L1, we can create a factory contract, and this factory can deploy the necessary configurations and contracts for each new chain that wants to join.
And the magic of Create2 comes into play here for deterministic contract addresses, right? How does that benefit this superchain? Sounds a bit technical.
It is a bit technical, but it's quite clever. By using Create2, the addresses of the bridge contracts associated with a particular chain configuration become predictable. They're deterministic. This means that even before a chain's bridge contracts are actually deployed, the addresses can be known. This enables what's called counterfactual chain deployment. You can interact with a chain that hasn't fully been deployed yet.
Mm-hmm.
And it also allows new chains to inherit the standard security properties defined on L1 automatically. It's kind of like knowing the address of a new house before it's even built, just because you know the blueprint and the plot of land.
Okay, interesting analogy. The second key upgrade is deriving OP chain data using this chain factory. How does that work, and why is it significant?
Right. Bedrock already introduced the concept of deriving L2 chain data directly from L1 blocks. By extending this with the on-chain chain factory, Optimism nodes will be able to deterministically sync any OP chain simply by having an L1 address and a connection to L1. Because the entire configuration of the OP chain is defined right there on L1, nodes can independently compute the correct state of any chain. And what's fascinating here is that no separate proof system is needed just for this chain derivation process itself. Invalid transactions are simply ignored during this local computation. However, as we'll discuss, a proof system is still absolutely crucial for withdrawals.
Right, that leads us perfectly to the crucial aspect of permissionless withdrawals. The current system has a permission proposer role, which doesn't really seem scalable for a superchain with potentially, hundreds or thousands of chains. What are the proposed solutions there?
Yeah, that's a bottleneck. The key innovations here are withdrawal claims, which allow anyone to initiate a withdrawal, not just a permission party, and on-demand proposals, which remove the need for proposers to submit withdrawals at fixed intervals. To enable this permissionless system, though, a robust proof system is essential. Initially, the plan is to use a fault-proof system. Anyone can submit a withdrawal claim along with a bond. If that claim is challenged and proven invalid, the challenger receives the bond, which incentivizes accurate participation.
Okay, but to arbitrate disputes in this initial phase, there's a reliance on a trusted set of chain attesters. That sounds like it introduces a degree of centralization, at least in the short term.
It does, yeah. That's a fair point and something acknowledged. In the initial implementation, a set of trusted chain attesters will act as the final arbiters in case of disputes. The system is designed with a safety over liveness principle, so even if these attesters were malicious, they couldn't unilaterally steal funds. But in worst-case scenario, they could temporarily prevent withdrawals until an upgrade fixes things.
Okay, safety first, but still.
Mm-hmm.
What's the plan to move away from that trusted model? Are there concrete steps or a timeline?
The long-term vision, absolutely, is to move towards trust-minimized proofs like Canon. The goal is to eventually phase out the reliance on these attesters completely. The timeline for that full transition really depends on the progress and demonstrated robustness of these trust-minimized proof systems. There's ongoing research and development. It's a major priority.
Good to know. The ability to have a configurable sequencer per OP chain modular sequencing is another important upgrade mentioned. Why is this significant for the superchain's evolution?
Modular sequencing allows the deployer of an OP chain to specify which entity will act as its sequencer. This is a crucial step towards greater sequencer decentralization, allowing for more choice. And importantly, even with different sequencers, the security model provided by the Superchain bridge, which is governed by the Optimism Collective, remains consistent. It ensures both safety, through the proof system we just discussed, and liveness. Liveness is ensured because users always have the ability to submit transactions directly to L1 if needed, bypassing a faulty or censoring sequencer. This also opens the door for permissionless experimentation with various sequencing protocols, which could lead to more efficient and user-friendly standards over time.
Okay, so more choice, but still with that safety net. Makes sense. Finally, a shared upgrade path for all OP chains seems like a logistical necessity for a unified superchain. How will that be managed?
Yeah, managing upgrades across potentially many chains needs a system. The proposal involves a decentralized security council that will govern upgrades. This council will have the authority to update the chain attester set, especially important in the initial phase, initiate contract upgrades with a built-in time delay for scrutiny, and even trigger an emergency bridge pause if absolutely necessary. This pause mechanism is another example of that safety over liveness principle. In an extreme situation, like a major key compromise affecting a significant portion of the Security Council, the bridge could be frozen, preventing further withdrawals or upgrades until the issue is resolved by governance.
And there's even a mention of an L1 soft fork upgrade recovery mechanism as a sort of ultimate last resort to unfreeze the bridge. That sounds quite drastic.
It is. It's definitely drastic. This mechanism would theoretically allow Ethereum L1 itself to initiate a bridge upgrade through a soft fork, essentially bypassing the normal governance processes within the Superchain bridge contracts on L1. However, it's explicitly stated that this is a potential recovery option being researched mainly for completeness. It is not currently endorsed due to the potential systemic risks it could introduce to Ethereum itself. The hope really is that it will never ever need to be used, but its theoretical existence could act as a deterrent against certain kinds of malicious behavior.
Okay, a deterrent, a last resort. Got it. So putting it all together, these upgrades, the chain factory, the data derivation, permissionless withdrawals, modular sequencing, shared upgrades, they're all designed to deliver on those core superchain properties we discussed earlier, right?
Exactly. Shared bridge, cheap deployment, configuration options, secure cross-chain interactions, all while leveraging the shared L1 for transaction ordering. These changes lay the technical foundation for the initial superchain. However, the documentation is also refreshingly candid that this initial version won't be perfect. It won't be without its limitations, and it outlines potential future enhancements needed to fully realize the vision.
Yes, the extending the superchain section highlights some anticipated pain points. Things like the initial reliance on trusted attesters, potentially slow and asynchronous cross-chain transactions, maybe L1 data availability limitations becoming a bottleneck, and the lack of really user-friendly multi-chain tooling. Let's touch on some of the proposed solutions for these. Multi-proof security aims to address that reliance on trusted attesters, right?
That's correct. The goal is to replace those trusted attesters with permissionless on-chain proof systems, like Canon, as we mentioned. But beyond just replacing them, the idea of a multi-proof system is envisioned. This means potentially having multiple different proof systems verifying the same state transitions. It provides redundancy and much greater confidence in the security of withdrawals. If one proof system has a bug, another might catch it.
Okay, redundancy for safety. And to tackle the slowness of cross-chain transactions, which comes from those challenge periods in fault proofs, the idea of low latency L2 to L2 message passing comes into play, possibly using modular proofs. How would that work? Sounds complex.
The beauty of the OP Stack's modular proof system is that it allows for the use of multiple proof types for the same chain. This opens up the possibility of using one proof system that offers low latency bridging, maybe something like a validity proof, which could have some different trust assumptions or trade-offs alongside the high security but higher latency fault proof mechanism. This would allow developers to choose the appropriate bridging method based on the value and sensitivity of the assets or data being transferred. It's kind of like having both a fast courier for less valuable items and a heavily secured armored truck for the really high value transfers. You pick the right tool for the job.
That makes intuitive sense. Now, the lack of atomicity in cross-chain transactions is a known headache. How does the superchain aim to enable synchronous cross-chain transactions?
The proposed solution here involves using a shared sequencing protocol across multiple OP chains. If several chains opt into using the same shared sequencer or coordinating sequencers, they could potentially include related transactions in linked blocks atomically. This would be a huge game changer for applications like cross-chain arbitrage or complex DeFi strategies like flash loans, where the success of one part of the transaction absolutely depends on the immediate success of the others across different chains.
Yeah, atomicity would unlock a lot. Scalability also hinges heavily on data availability. The Alt Data Availability Layer, or Alt-DA protocol, is suggested as a way to potentially go beyond L1's capacity. Can you explain that concept a bit?
Sure. The Alt-DA protocol allows OP chains to utilize alternative data availability providers in addition to or instead of L1 Ethereum. Transaction data would still be committed to on L1, probably via a hash commitment, but the full data itself might reside with a specialized DA provider, like Celestia or Eigendia, for example. Crucially, a challenge mechanism would need to be in place to ensure that data remains available when needed for verification or dispute resolution. This approach could significantly increase the data throughput capacity of the superchain, making it suitable for really high throughput applications, like maybe gaming or social media, that might struggle with L1DA costs.
Interesting. And finally, to make all of this actually usable for developers and end users, there's a clear need for multi-chain app frameworks. What kind of tooling is being considered there?
Yeah, the user and developer experience is critical. The focus here is on creating tools that abstract away the complexities of building and interacting with applications across multiple chains. Ideas floated include things like content addressable smart contracts that could potentially have the same address on all OP chains, simplifying discovery. Also, standards for cross-chain state management, so apps can easily read data from other chains. And maybe a unified superchain RPC endpoint, like one address you connect your wallet to, that intelligently routes your request to the right chain. It's all about making the experience feel like interacting with a single powerful computer rather than juggling connections to a bunch of separate ones.
So the superchain vision is incredibly ambitious, aiming for, well, a radically decentralized internet and truly scalable web applications. That sounds like the initial release is going to be a significant milestone, but yeah, there's still a long road ahead.
That's absolutely right. The initial superchain will represent a major leap forward, no doubt. But there's still significant development and research needed to address those remaining pain points we discussed and fully realize the potential. It's an ongoing journey.
And this is where the community comes in, right? The documentation really emphasizes that this is an open source effort, and contributions are not only welcome, but could also potentially be rewarded through things like retroactive public goods funding.
Exactly. The challenges ahead, they actually present really exciting opportunities for developers, researchers, and builders to get involved and contribute to building the future of blockchain infrastructure. It's a collaborative effort.
Well, this has been a fascinating deep dive into the superchain. It's clear that it's a complex and evolving concept, but definitely one with the potential to fundamentally change how we think about and interact with decentralized applications. Thanks for unpacking it all with us.
My pleasure. It's an exciting journey, as I said, and we're really just at the beginning stages. Lots more to come.
And to you, the listener, definitely stay tuned to Superchain Vibes for more updates as the Superchain vision continues to take shape. There's a lot more to explore in the world of Ethereum scaling, and we'll be right here to dive into it with you. Maybe you're a developer intrigued by the possibilities of modular sequencing, or perhaps the potential of those multi-chain app frameworks we touched on. This is a space just ripe with opportunity for innovation. The insights we discussed today are really just scratching the surface. Maybe consider, what new applications or user experiences could truly be unlocked by a genuinely scalable and interconnected blockchain ecosystem like the Superchain aims to be. Something to think about.